Welcome to A Third Way. I am your host, Richard Garner. Today's episode brought to you by our friends at ZeroDB. What is ZeroDB? It's a drink, but it's more than a drink. I'd say it's a life solution in a stressed out world of high anxiety levels and unfortunately all too many options to caffeinate or lift your energy levels artificially. There aren't enough options. In fact, there are very few, if any, that actually help you quiet the noise. And that is what our friends at ZeroDB have brought to us. Again, it's not just a drink. I'd say it's a life solution. Go to drinkzerodb.com and find out where you can either order it on the website or check the store locator. It's in Whole Foods and a bunch of stores probably near you. drinkzerodb.com, check it out and quiet the noise. Dr. Jill Tarter was the inspiration for Jodie Foster's iconic character Ellie Arroway in the classic sci-fi movie Contact. As the former director of the Search for Extraterrestrial Intelligence, or SETI, Dr. Tarter has been searching for intelligent life in the universe long before it was cool. And now, as the world prepares for a seemingly unprecedented level of disclosure of information as to just how much we really do know about life beyond the universe, we should all remember that it was the efforts of the pioneers in the field like Dr. Tarter, whose work paved the way to the imminent revelation we're on the verge of finally, once and for all, knowing, are we alone in the universe? And we are now joined by the aforementioned Dr. Jill Tarter. Dr. Tarter, welcome to A Third Way.
Oh, thank you, Richard, for having me.
Well, and it's not the first time I've had the pleasure of talking with you about your work, going as far back as when you were the director of SETI and even as recently as a couple of years ago. And what fascinates me, well, I mean, pretty much every aspect of the conversation about life beyond the planet Earth is fascinating, whether we're talking extremophiles, which we'll talk about, whether we're talking about quote unquote intelligent life in the universe and the search and the exploration aspect of that. But what fascinates me as I sit here today is the evolution of, let's say, the sort of the public perception. And we could even sort of dive deeper into that of the scientific community, the media, and let's say just people overall. But before we get to kind of my perspectives on that, I'm more interested in your perspectives on that. And maybe before we get into that, you can sort of bring us back, before people sort of became familiar with you and SETI, how you sort of decided to go in this particular direction, and then kind of what it opened up for you with SETI and your work.
Well, my getting into this field was a very lucky accident. I knew how to program an absolutely ancient computer called a PDP-8S. That was donated to Stu Boyer, a professor at UC Berkeley, who wanted to use UC Berkeley's radio telescope at Hat Creek to do a SETI search. And without money, he went begging for equipment, and this computer was given to him. And then there's no language for that computer. It had to be programmed in Octal. He had to set all the ones and zeros, and I did that as an entering graduate student. So he came and recruited me to work on his project because I knew how to program that old PDP-8S.
Well, this is why you have these conversations, because those types of stories, like I've known your work for a long time. I had no idea. And I love when we find out about how people whose celebrated careers spanned, in this case, decades. And we find out that it wasn't necessarily, this pursuit from, your whole life wanting to, it actually ends up being, to your point, a bit of a lucky accident. But I would have to imagine that when somebody sort of introduces to you the idea of this is what we're looking to do, especially then, it wouldn't have been something you'd be like, oh, okay, sounds cool. Or maybe you did. What was your sort of first reaction when the idea of starting to listen, to explore for signals in the universe or in the galaxy? What was your first reaction when that was introduced to you?
Well, Stu's recruiting technique was to hand me a copy of the Cyclops report, which was the result of an engineering summer design study. And that was written mostly by Barney Oliver, who at the time ran HP Labs. And I read that document cover to cover. It was pretty dense, but I realized that starting out with my undergraduate degree in engineering and then a PhD in astrophysics, that I was in the right place at the right time with the right set of skills to maybe do something to try and answer this very old human question. And so I just got hooked. I thought, wow, who would have expected that by starting out as an engineer at Cornell, I would end up with the opportunity to tackle this very old, very important human question. So I really did get hooked, and I've stayed hooked ever since.
Cornell, correct me if I'm wrong, Carl Sagan, was he not also, and would you guys have crossed paths?
Not at Cornell. I had left by the time he came to Cornell, but we certainly crossed paths at other places and other times.
Well, I would, yes, and of course I would imagine, obviously, considering the where your work and your lives overlap later on. So as you sort of embark on this journey, and I mean, I've heard multiple people, including yourself, try to articulate what, of course, needle in a haystack comes up a lot, but I remember you using the analogy of, look, a glass of water in the Earth's oceans as to kind of what the mapping of what you could focus on at a given time. And again, technology, as you've cited, big part of it. And that's where we're going to go later in the conversation as to how the game is changing. But, of course, we all want to be part of a story that maybe surprises people. But I imagine out of the gate, it had to feel pretty daunting as to what you were trying to do and what the ability to be successful would have been early on.
Well, there has been something like 14 or 15 factors of 10 in the improvement of our ability to search today versus when we started. So we've all been riding that exponential improvement in computing and the improvement in receivers and antennas. So it's been a long journey, and it's fortunately, I didn't actually do the glass of water out of the Earth's ocean calculation until SETI turned 50. So we just, the last sentence in the 1959 paper by Cocconi and Morrison says it best. It says, the difficulty, let's get this right. The probability of success is difficult to calculate. But if we never search, the chance is zero. And that's always been the attitude that people who have been involved in this field has been. We don't really know what it will take to find an evidence of someone else's technology, if indeed it's there. We always have to admit that the answer to the "are we alone" question may be yes, we are, or at least practically we are. So as we have improved our capabilities of searching, as we have broadened our thinking about what might be indicative of someone else's technology, to go beyond radio signals and optical signals, and as we think about the new instruments that are being built for astronomers to explore the cosmos, and we think about the kinds of things they might find that would be indicative of large-scale astroengineering, of what we now call techno-signatures, rather than just SETI. We always reserve the right to get smarter.
Yeah, it's that type of objectivity that you like to see, and humility actually is probably maybe the better word for what really underpins the best science. In this particular regard, like anything, it becomes a job, like whatever anyone's doing, and, they get up in the morning, they go to work, and they have, good days and bad days. We're all human beings. But how often did it occur to you, whether it was through conversations with other people or, maybe conversations with other colleagues, as to the stakes of what you were doing, and that, that big if, that day that you could come in and actually have some sort of confirmation, because again, it wasn't just the objective of maybe finding a techno signature or finding evidence of are we alone, but that becomes a BCAD period for the human species. Like there's before and after that particular discovery. Was that ever, I don't know, overwhelming? Is that the right word?
We've certainly held lots and lots of workshops over the years about what this sort of detection might imply for society. And at the end of the day, when you bring in all these experts, their answer to us is the world will respond to the announcement of the detection of another technological civilization in accord with whatever social norms are in place, whatever people are doing in the world about other subjects. That is, we can't really predict how the world's going to react because it's going to depend on the context of what's going on in the world when this gets announced. So we've tried to think about that in a responsible way, to know what should be our role in providing this information to the world. But at the end of the day, if you wake up in the morning and you say, today's the day I'm going to detect a signal, you're probably going to go to bed at night disappointed. However, if you wake up in the morning and say, I'm going to figure out some way so that I can make the search better today than it was last week, then that's very satisfying. You can see progress, you can see improvements, you can work through a lot of different areas that are scientific and political and social and make a difference. But you can't plan on ever being successful within our lifetime, within your lifetime. That's the reason that one of the things that we're now trying to do within the SETI community is to build an endowment for this kind of scientific exploration, because we realize that it might well be a multi-generational pursuit. And we have to be able to build a platform that provides a small amount, it's not huge dollars, but a small amount of funding over a very long period of time. And the only good financial model that we've discovered is an endowment. So that's where we are. We're trying to raise funds for that.
So where do you see that potentially intersecting with, because there's no shortage of billionaires, it seems, these days that are looking to bring people to space, and that's a bit of maybe another conversation. And famously, even in the movie Contact, which we'll talk about in a sec, but of course there was that role that was, again, similar in that there was somebody with the deep pockets who had a vested interest one way or the other. And it would seem today that there's obviously ways to crowdfund and a whole bunch of other ways, and the interest level has never been higher. So do you feel confident about the future, the endowments, and the ability to have the resources to continue this exploration?
Well, we're working on it. We haven't solved that problem yet. I welcome any introductions to billionaires that you might have, sitting around. But so it is something that we're being very thoughtful about. And think about the fact that, all right, I've said this might be a multi-generational exploration. Well, that means that I need to recruit and train my replacements, right? And SETI, although much less so today than 50 or 60 years ago, is still considered a long shot. It's still one of these things that you can't promise that you will succeed in your professional career lifetime. So that's a hurdle to recruit people into that kind of situation. But then if you say, oh, and not sure I'll be able to make your paycheck next month, right? That's a real hurdle. So we're concentrating now on an endowment and bringing in a new generation of researchers and engineers. And of course, with the findings of extremophiles and exoplanets over this past 60 years, that's fantastic, because now it just seems like the next question to ask about these potentially habitable exoplanets is are any of them inhabited, in fact? So it's a good time to be thinking about this kind of question.
Well, it certainly feels that way. And I mean, we've talked before about, whether it's this last year or the last 5 years, but certainly in the last 18 to 36 months, there's, it shifted from and even the coverage. That's the other thing I've noticed, is that even if there was something interesting that was being reported around, not so much a UFO sighting, but maybe sort of something astronomical, the reporting on that would still be kind of, you'd have two anchors kind of, well, and some crazy news today. And there'd always be this tendency to, the uncomfortable laughter. There'd be a joke about Martians or something like that. And these days, whether it be, the reports of the signal, we just had somebody, a Harvard professor touring, recently talking about what, from his perspective was potentially an alien craft. We have the Pentagon releasing things. We have governments around the world. And then to your point, the two biggest, let's say, I don't know, confirmations of something that really sort of allow people to project and scale further, which are extremophiles, which, when I grew up, the idea of a life form existing in anything other than optimum conditions was silly. And then, of course, the idea that there were other planets that could potentially be habitable was also sort of dismissed. Those two things, I think we're up to 4,000 plus exoplanets now. We're finding, biological life in the Antarctic ice caps. We're in volcanoes. So to your point, it feels very encouraging. Would you go as far as saying imminent?
Oh, I think that, well, one of the bad things about being old is that I will probably not be around when these new fantastic discoveries of life beyond Earth take place, either within our solar system or by virtue of finding biosignatures or technosignatures from some distant planet around another star. The thing that to me epitomizes this is now very credible areas of research is the fact that with the TRAPPIST-1 system, a small red star with 7 Earth-sized planets orbiting around it, that showed up above the fold in the New York Times in full color, right? That makes it pretty credible. And the fact that I'm disappointed about is that now people think we know what those planets look like because some artist did pretty color drawings of them. And of course, we don't. We've never seen those exoplanets, but new telescopes are being built, and we will eventually have the ability to observe those individual 7 Earth-sized planets. And the thing that tickles me is to think about, well, they're at different distances from their star, so they should be at different temperatures. They shouldn't be the same in any way, but suppose when we can actually image them, we find that 2 or 3 or 4 of them, in fact, are all the same. And they're the same, perhaps because somebody geoengineered them to be, right?
Wow.
So that would be a technosignature. I would be delighted to be part of that discovery.
Well, I mean, it's a great it's a great segue to the conversation about the James Webb Telescope. And again, I'm on the outside of looking in as a as an interested third party, but obviously somebody who's been immersed in it at the level that you have and are. I remember when Hubble was launched. It was '90s, right? I mean, it was, I think, early to mid '90s, and that was a game changer from what we thought our galaxy and what the rest of the universe looked like, and certainly in terms of the number of stars and the number of planets. I mean, that went from some sort of far off projections to essentially what you'll hear people say today is just in the Milky Way galaxy alone, there's probably 200 billion plus stars. And then people project that there's probably something close to, I don't know, 100, 200 billion galaxy. I mean, these are numbers that are beyond our ability to fully grasp. That's with a telescope that's a couple of decades plus older. What can we expect in terms of, a telescope that's being launched now? And we all understand technology to know that the difference in 20, 25 years is massive. What should we be expecting in terms of the game-changing ability to see beyond not just our solar system, but even further?
Right. So the Hubble didn't really get to planets, but what the Hubble did, the amazing thing that the Hubble telescope did, was the Hubble deep fields, staring at a spot in space that we thought had nothing in it. And then by integrating for hundreds of hours, finding these thousands and thousands of distant galaxies and showing us indeed how full our universe is of distant galaxies. And this opened up all kinds of wonderful areas of investigation. And the JWST is probably going to do exactly the same thing. If we get it to L2 and if it all works, because there's no opportunity to go fix it the way we did with Hubble, then it will be able to do a number of things that we already know about. It will be able to explore some nearby exoplanets. It will study the early history of the universe. It will do lots and lots of wonderful science. But if history repeats itself, there is an astronomical tradition that we've been very fortunate to benefit from, which is that every time we build a new instrument to look at the cosmos in a new way that we haven't done before, yes, that new instrument does work on all the problems that we talked to funding agencies about what it was going to solve. But the very best thing that that new instrument historically has done is to show us something that we never expected, because we're looking at the cosmos in a new way. And I hope that the James Webb has that kind of experience, that we will find something that we didn't anticipate when it's working.
Yeah, and that's, I mean, I sort of gasped there when you said that, because that's the other sort of great part about exploration. As you talked about, often we sort of get caught up in what we believe, but I guess technically science isn't supposed to be about what you believe. It's supposed to be about exploration, right?
Well, science is supposed to be about what is, right? And we need often to explore in different ways in order to find out what's actually happening and what is and how it is. And then sometimes we can even figure out why it is. But belief is not the right verb. Scientific exploration is what we're all about. And it doesn't matter what you believe, what I believe, what someone else believes. The universe is as it is. And we have the great privilege of exploring it and trying to understand it.
So take us back a little bit to that period where, again, I guess it's so Carl Sagan would approach, like, how does, first of all, the book and then ultimately the movie, I imagine it would have been, I imagine you would have met Jodie Foster at the point of developing this, and then not just the sort of the pre-production and the production of the movie itself, but then the way it was received, and then, you know, while it was out, you know, that sort of really captured a lot of people's imaginations, and it holds up well today, I would say. But I mean, outside of it being exciting, it must have felt seminal also in some ways.
Well, I did have the privilege and the good fortune to talk with Jodie Foster and work with her. And she's very clear that her role was not going to be to teach any science to anyone, but to portray what scientists in general are like. You know, they're stubborn, they're passionate, they have good points and bad points. They're humans, and I think she did that really, really well. The unfortunate thing with that movie is that I left Arecibo a couple of days before this seminal scene in the movie was shot, and it turns out that is just a huge innumeracy, right? It's kind of the romantic link in the film, and Jodie Foster is sitting there with Matthew McConaughey, and she's looking up at the sky and saying, "Oh, there, you know, hundreds of billions of stars out there, and if only 1 in a million of those had planets, and if only 1 in a million of those planets had life, and if only 1 in a million of those life forms had technology, there would be millions of signals for us to find." And that is so wrong in terms of the numbers. She's taking 10 to the 11, multiplying by 10 to the minus 18, and coming up with 10 to the 6.
And an easy fix if you're there that day.
Yes. But I wasn't. And apparently Carl, who was working on the movie, as unfortunately he passed away while it was still being edited, he had found this mistake in the script and had tried to get it fixed a couple of times, but it didn't happen. So we are faced with that innumeracy today. And when I talk to the production team and they say, "Oh, Dr. Tarter, how many people do you think are going to get that?" And you go, yeah, that's the problem. We don't teach our young people very well how to deal with orders of magnitude, right? So that's a failing of our educational system.
That's interesting, because I think about what surprises me often is our inability to easily scale or project.
Right.
From and I don't want to use the word visionary standpoint, but let's say, for instance, I'll be talking to somebody about, you know, let's use AI as an example, right? And you would say something like, "Well, if we're already doing this, like, then imagine," you know, or science is actually a good example, because you get a lot of absolutism where people will forget that, man, pretty much everything we've ever thought at some point, medically, scientifically, or otherwise, which was with absolute certainty, has been revised, updated, sometimes dismissed altogether, when, to your point, we've developed new technology or new ways to whatever. And so you'll say to somebody, "So can you imagine what we think today will be laughed about in 100 years or looked at differently?" And you get a lot of blank stares. And I find that there's something inherent about us that has a has difficulty with that ability to imagine, let's say, in a sort of in an educated guessing type of way, what things might look like 20 years, 50 years, 100 years from now.
Yeah, we have in San Francisco, there is something called the Long Now Foundation, and they are very concerned with exactly this kind of thing, where for young people, the future is sort of at the tip of their nose. They don't see very far, and they are trying to stress that was okay in the year 1000, when you were going to grow up and do the same thing that your father or your grandfather or grandmother did, right? Things weren't changing very fast. But now that your circumstances, the technology that you interact with, the mindsets of politicians and other scientists it's all changing so rapidly that we have lost this ability to look into the long future and to think about whether we have a long future. And I very much. They've built inside of a mountain. They've built a clock that will work 10,000 years into the future, as
What?
long as humans wind it. And that decision of winding it is to make that clock be part of the culture of humanity, right? If it sits there and works for 10,000 years and nobody ever comes and sees it and nobody thinks about it very much, it's not going to have any impact. But by making it necessary to wind that clock, you constantly are able to remind people to think about a long future. And that's one of the things that I really like about working on the search for technosignatures. I think that if I get to talk with people and they listen to me for a while, I think that what I'm able to do is to hold up a mirror to the audience and say, see, in that mirror, you are all the same when compared to something that may have originated and evolved in a different world out there. And I like to point out the fact that if SETI ever succeeds, then we'll know that it's possible to have a long future. Doesn't mean that we're going to get told how to get there. But if SETI succeeds, it can only do so if another technological civilization is close enough to us to be detectable. And that's not only close in space, but overlapping in time, cotemporal. And in a 10 billion year history of this galaxy, you're never going to get two civilizations that overlap in time over that 10 billion year span, unless, on average, those technological civilizations persist for a very long time. And that's long in cosmic terms, not human terms. So if they were able to make it through the technological adolescence that we find ourselves in, then somehow we could as well. And I think
I mean, it's interesting because it reminds me of I have to imagine a less cited Jill Tarter inspired character in a movie. Everybody, of course, talks about Contact and Jodie Foster. I'm rewatching one of my favorite movies the other day with one of my favorite people, Britt Marling. And of course, the movie is Another Earth. If you haven't seen it, it's a small independent movie. I absolutely love it. And it's about, and just quickly, it's about literally a mirror version of Earth all of a sudden sort of comes into our orbit, and I won't spoil it for you, but it fascinates the world, and you can literally see it like you see the moon. But I remember one of the great scenes is the director of SETI, and her name is, it's like Joan Tesler, but I think it was an homage by using your initials. And then they have that conversation with essentially your sort of mirror double. And that's certainly don't want to go into that, like the areas of physics around, sort of parallel universes and whatever. But it seems from when you started down this road, not only has technology changed a great deal, but our understanding of physics, quantum physics, astrophysics has changed significantly enough that maybe the questions aren't as I don't want to say materially based, right? Like, for instance, I'll hear people say often, well, Alpha Centauri, it doesn't matter what's out there. We can never go there. And we interviewed D.D.O. Kellogg's. D.D.O. Kellogg's is the Nobel Prize winner who found the first exoplanet. But he had no problem saying we would never be able to go there because it was in distance, too difficult, too far. But I find it interesting that we still will apply our way of thinking to potentially species that have figured things out that we haven't thought of yet. And you talk about this overlap in time, but I suspect that even if we were close within 100 years, there might be other species that have figured out, let's say, how to go through a wormhole. Is that crazy?
We can't do it, right? But that doesn't mean that it can't be done. We don't have any definitive physics that says, no, this is impossible. We have a lot of things that say, no, it wouldn't work, or no, that's going to be difficult. But, we don't know what we don't know. And I think that science is all about figuring out the unknown. And it's so in astronomy right now, scientists are puzzling over what we call fast radio bursts. And although there are probably 10,000 of these going off on the sky every day, they only last a millisecond or shorter. And we hadn't ever seen them or detected them until we did accidentally about a decade ago. And how can it be that 10,000 things are happening on the sky and we didn't know about it? Well, it can happen because we didn't have the right instrumentation. We couldn't count those radio photons fast enough and being able to look at all the sky all the time. Now that we can do some of that, we're finding these, and they are probably going to turn out to be something we call a magnetar. And why some do this and some don't, it's not clear yet. But now that we have the ability to observe these, we're puzzling over what they are. But, go back a decade and nobody had a clue that this was happening. And yet, eventually, we built the right kind of instrument to be sensitive to these. So, yeah.
Of the things, because I was certainly going to, I want to know what, the day you first heard about, fast radio bursts. I mean, I know that I remember in conversations I remember people saying like, oh, wow, like Jill Tarter and SETI, they must, this is within their sort of area of understanding. It must have been super exciting. And then, of course, like we mentioned, recently there's been, the discoveries of the, and I can never say the name right, the long Hawaiian name of the
it's Oumuamua.
Thank you very much. Oumuamua, which, again, got an incredible amount of coverage recently with, again, a Harvard level professor stating that, there's a belief that that was artificial, or that was, potentially a spaceship. Of course, like I said, you've had a lot of governments, you've had high level Pentagon files released over the last X amount of time. A lot of things that, were mocked or dismissed before now becoming, infinitely more, being taken seriously. Of these types of things that have happened over the last, few years or longer, what got your attention the most, and what leaves you with maybe something that you're most encouraged about?
Well, Richard, when the Oumuamua detection took place, at least I remembered my childhood science fiction reading of Arthur C. Clarke's Rendezvous with Rama. So, of course, we used our telescopes, the Allen Telescope Array, to observe it over a wide range of frequencies. And we didn't see anything that we couldn't explain by our own technology. Others, the Breakthrough Listen group also looked at Oumuamua. Others have observed it. And there is, I think, consensus in the community, but of course this is what Avi Loeb objects to, that we can come up with a natural explanation for it. We do not have to invoke aliens. Right? And I think we should keep an open mind, and we certainly did. We used observing time to investigate it. But I think that what will happen is that as time goes on, if indeed this is a natural object, we will, for example, with the Large Synoptic Survey Telescope, the LSST, we will find many more of these. Right? And if it's not natural, we come up empty after a number of years. That's going to be very interesting. So,
the late Stephen Hawking famously or infamously stated that and I'm paraphrasing here a bit, but that he was worried about us letting our presence be known, because from his perspective, and this could be just a personality disposition, but from his perspective, he felt that because of the likelihood of any other species being out there, that they would be more than likely advanced far beyond our technological capabilities, and to the point that he worried that it could be as a wide of a gap as it might be for us and microbes, or us and ants, for instance, where it's not even malevolent, but our disregard for this level of species that's so unevolved relative to us would allow us to potentially, exploit it, use it, experiment it, whatever. But anyways, his overall point was, let's keep it quiet here. We don't want to, whatever. And, I don't think it's a stretch to say I wouldn't imagine you would concur. But in that regard, I know it's come up a lot where you have people debating, would something outside of this earth be threatening? And then you have other people who just think it's 2 + 2 = 4, that of course a species that's evolved far beyond our state would be more benevolent, more beyond our sort of capacity to compete and to war. You feel, generally speaking, and obviously you wouldn't be doing the work you were doing, that is more than likely the scenario. Is that fair to say?
Yeah. Stephen said, it didn't work out very well for the natives when Columbus showed up on their shores, right? And so we want to avoid that. But I actually am much more in the Stephen Pinker camp of the better angels of ourselves, right? Stephen Hawking was presuming that they would come here, right? And that's why there would be a threat. Well, if they could come here, then obviously they are technologically more advanced than we are. They are, therefore, in my opinion, a much older civilization than we are. And I don't understand how you can get to be an old technology, an old civilization, unless you lose the aggressive tendencies that have thus far helped us evolve to be intelligent and technologically savvy. So again, I think that cultural evolution will tend to wipe out the aggressive tendencies, and then a much older civilization will not be a threat. But that's an opinion. I have an opinion. Stephen Hawking had an opinion. We don't know what's right. We can use analogy, look at what's happened to us over time. And that's, again, what Stephen Pinker has done. And try and project that cultural evolution into the future. But still, it's going to end up being an opinion. And, if they can get here, they're going to write the rules, not us.
Well, it's an interesting tie to what you said earlier, because the benefits for us to be able to make contact, so to speak, with a society, a species that's far exceeded us, is to be able to potentially learn, well, how did you get beyond the challenges that we currently face, right? You could make the assumption that they would have had similar aspect, whether it be climate change, whether it be war, those types of things, and that by being able to see that, well, this is how we ultimately move beyond that we could benefit from that. I share your perspective on that, not out of optimism or hope. I think it's more 2 + 2. It just feels, but again, to your point, it's an opinion. It's subjective in the end. Like you said earlier, we don't know what we don't know. So before we let you go, I know you've been asked this a lot, and it's so difficult to project, because it's almost like being asked, like, name a color that we don't know of. Like it's like the mind can't go there. And of course, we have our sci-fi visionaries that have painted some pictures, whether it be Star Trek, whether it be, whatever it is, as to what the future might look like. And, there's no shortage of opinions about that. I know I said imminent earlier. Maybe the right word was inevitable, which I believe is the right word. Do you have any? Do you lie in bed at night and imagine? Have you ever sort of envisioned what a world post discovery, post first contact could look like?
Yeah, I think about it, but probably not in the way that you're imagining. I want to make sure that we don't have this detection, this discovery, set up another set of inequalities around the planet. I mean, there's so much inequity today, and I worry that depending on the location of, in my case, it would be a SETI signal, not another kind of technosignature. I worry that the location of that transmitter might be such that it enables certain countries to have access to that information, and it doesn't allow other countries to be able to see that transmitter. And then there would be a tension between the haves and the have-nots about whether information that was being received from a distant transmitter was being properly shared. And I just don't want to end up setting up another kind of tension in this world. We don't need that. So hopefully wherever we find it is going to be close to the equator, and everybody, at some point during the day will be able to see the signal.
Well, I hope personally that certainly I hope that it happens, that I'm alive for it, but more than myself, I would say it would be almost unjust if you weren't able to sort of share in that period and that moment, with so much of it being built on your shoulders over the years. And so my fingers are crossed, days, weeks, months, years, who knows. I'm probably a little optimistic there, I'm sure, but I am, regardless of when, I'm encouraged, I'm excited even, and I think that we'll all benefit from that sort of widening of our perspective. And I know that people will be looking back, from years from now, and honoring and celebrating the work that you and your team did to really sort of get us all started on this, this massive game-changing discovery. So for that, on behalf of everybody, here at A Third Way in the audience and our community, I would just like to say thanks for all the work that you've done for us.
Well, thank you, Richard, and thank you for having this conversation with me.